Hello students, today we are going to study next point, multiplexer tree. Multiplexer having more number of inputs that can be obtained by cascading two or more multiplexer with less number of input is called as a multiplexer tree, and this is called as a multiplexer tree. This concept will clear by solving the problems. Means multiplexer having more number of input line, but that can be obtained cascading of one or more number of multiplexer with less number of input is called as a multiplexer tree. This sentence is very important. By this sentence we solve the multiplexer tree. We clear the exam concept of that or solving the problems. That first problem, obtain 8:1 multiplexer. Obtain 8:1 multiplexer using 4:1 multiplexer. Using 4:1 multiplexer. First, how many obtain 8:1 multiplexer by using 4:1 multiplexer? 4:1 multiplexer. So first, how many 4:1 multiplexer required to obtain 8:1? That cascading of two 4:1 multiplexer results 8:1 multiplexer. And for 4:1 multiplexer there are the 4 inputs. So but we obtain 8:1 multiplexer. 8:1 require 8 input. So there are the two 4:1 multiplexer required. And there are 8 all inputs D0 to D7 we get. And the select lines, that S1 and S0 of both 4:1 multiplexer are connected in parallel, whereas third select input S2 is used for enabling one multiplexer at a time, and that S2 is connected directly to enable input terminal of MUX1, whereas S2 bar is connected to enable terminal of MUX2. That first we draw the 4:1 multiplexer. There are required two 4:1 multiplexer. 4:1 marks. 4:1 marks. First mark required data input line D0, D1, D2, D3. Next D4, D5, D6, D7. This is the first requirement. First 4:1 multiplexer, second 4:1. Then 8 data input lines. After that 8:1 multiplexer, how many select 4:1 multiplexer, how many select lines? There are 2 select lines. There are 2 select lines, S1 and S0 are both 4:1 multiplexer are connected and in a parallel. That is the parallel S0, S1, S0, S1. This is the S0, this is the S1. Then 8:1 multiplexer required 8 data input line, 3 select input, 1 output. But 4:1 multiplexer, 4 input lines, 2 select lines, 1 output. So there are the 2 4:1 multiplexer required for 8 data input line, and from these 2 4:1 multiplexer connecting parallel, we take the connected parallel, whereas we get the select lines of the both multiplexer. And but 8:1 required 3 select lines, but 4:1 are the 2. Then for first multiplexer and second multiplexer there is a one enable input. And this enable is used for the cascading purpose. That is used for the cascading purpose. And for cascading purpose, so for first multiplexer we connect one NOT gate, and from this two enable, that first multiplexer and second multiplexer enable input, we get the third select line as a S2. Here we connect the NOT gate between the two enables, because at a time one multiplexer is enabled, one is a S2 is connected to S2 bar is connected to second multiplexer, and this S2 is connected to E. At a time only this third select line for enabling one multiplexer at a time. One multiplexer enable at time. So here we connect the NOT gate. This is the fulfill requirement for the 8S2 and one output. So this Y output, Y1 output, this is a Y2 output of mux 1 and mux 2. We combine and we connect here one OR gate and we get the final Y output. This is the multiplexer tree. What obtain? 8:1 obtained by using 4:1. 4:1, 4 input line, 2 select line, 1 output. But 8:1 required 8 inputs, 3 select lines, 1 output. So we take the 2 4:1 multiplexer, we get the 8 input lines, 3 select lines. For 3 select line, 2 select lines for we connect this parallel 4:1 multiplexer, 2 input lines of the 1 mux and second mux we connected and we get the S0 and S1. And for the third select line of 8:1 we connect that 2 multiplexer 1 and multiplexer 2 enable input, and in between that we connect the NOT gate, because that at a time for enabling one multiplexer at a time, and we get the S2 as a third select line of 8:1 multiplexer. This is the complete fulfill requirement of 8:1. 8 input line, 3 select line, 1 output line. For one output, for one first mux, second mux output we combine and we get the Y output. We get the Y output. So this is the multiplexer tree. Multiplexer tree having more number of input lines can be obtained. More number of input lines, that 8:1 8 input line, that more number of input lines can be obtained cascading of 2 or more multiplexer with less number of input is called as a multiplexer tree. This is the first problem. We obtain 8:1 multiplexer using 4:1. And the truth table for this multiplexer tree, that is the select inputs and output Y. This is the S2, S1, S0, S0, S1, S2. Then 0, 0, 0. So input 0, 0, 0 for the select line input is 0, 0, 0. So input is select, data input is select as a D0 and that as a Y1 routed, and we get the output as a Y as a D0. Y as a D0. Next select input line 0, 0, 1. So input is selected D1 and output is routed as a Y as a D1. Next 0, 1, 0. 0, 1, 0 for select line data. So input is selecting D2 and that D2 is routed as a Y output. Next 0, 1, 1. That is the select line data 0, 1, 1. So input is selecting as a D3 and that D3 output as a routed as a Y output. This is the mux 1 inputs. D0, D1, D2, D3 are the mux 1 inputs, and these inputs are routed as output. So mux 1 is a enable. Mux 1 is a enabled. First. Next, that 1, 0, 0. 1, 0, 0 means 1, 0, 0. That's for select line data 1, 0, 0. So input is selecting D4. So output Y2 we get here as a D4 and that output Y as a final we get as a D4. Next 1, 0, 1. 1, 0, 1, that is a D5 input selecting, output as we get as a D5. Next 1, 1, 0, that input data line selecting as a D6. So output we get as a D6. 1, 1, 1. That is a D7, and that these input lines D4, D5, D6 are for multiplexer second, and that output Y we get as a D4, D5, D6, D7. So mux 2 is a enable. So for the cascading purpose, E enable, both enable we connected here one on AND gate, because for enabling one multiplexer will be enabled at a time. One multiplexer will be enabled at the time. This is the obtaining multiplexer tree. Getting the obtaining 8:1 multiplexer using 4:1. Take another example. Obtain 4:1 multiplexer using 2:1 mux. Using 2:1 mux. How many 2:1 required? 4:1 obtained. So 2:1 having two input lines. that is D0 and D1 and mux 1. This is a Y output. Then 4:1 requirement, 4 input line, 2 select line, 1 output. But 2:1, 2 input line and 1 select line. Then how we obtain the 4:1? Then for resulting at 4:1, we take the cascading of 2:1 mux. So require the 2:1 mux as a 2. So this is a 2:1 mux second, and for this 2:1 data input line D2 and D3, and parallelly connecting both 2:1 multiplexer as a 1 select line as a S0, and we get as this is S0. Then Y1, this is a Y1 and this is a Y2, and we connect one final output Y. 4:1 require 4 input line D0, D1, D2, D3. 4 input lines we obtain by cascading 2:1 multiplexer. Both common, take one S0 as a parallel connecting as a, for 2:1 only 1 select line, but 4:1 require 2 select line. So first enable input, here we connect one AND gate, NOT gate, and second multiplexer enable, we cascade and we get the another select lines. Then this is the complete requirement of 4:1, 4 data input line, 2 select line, 1 output line, and that we get the another select lines. For 2:1 only 1 select line, but 4:1 required 2 select line. For that we connect or cascade the 2 enables, and in between the enable we connect the NOT gate, because at a time for enabling one multiplexer at a time, and we get the next select line as a S1, that 4:1 require the 2 select lines. Then truth table S1, S0, this is the select inputs and Y output. Select line data D0, 0, 0. So input is selecting 0, D0, that Y1 output we get, and final output Y we get as a D0. Next 0, 1. 0, 1. 0, 1 means input line selecting as, for select line data 0, 1. So output is input is selecting D1, and that D1 we get as a output as a Y as a D1. Next 1, 0. 1, 0 for select line data 1, 0. So data input is selecting D2, that D2 output is routed as a Y output. 1, 1. 1, 1, that is a D3 is selecting data input line. So D3 input line Y2 output we get here as a D3, and that Y output is routed as a D3. And in here mux 1 is enable, and here mux second is enable. Mux second is a enable, because between the two enables we connect, between two multiplexer for cascading purpose we connect the one enable input in between their NOT gate connect for enabling one multiplexer at a time. These inputs are for multiplexer 1, and that output is routed, so mux 1 is a enable, and D2, D3 these are the inputs for the 2:1 second multiplexer, mux second multiplexer input, so that output as a routed as a D2 and D3, so mux 2 is a enable for this. This is the multiplexer tree. You have to solve the many examples as a implement 16:1 multiplexer using 4:1 multiplexer, design 16:1 multiplexer using 8:1 multiplexer. You have to for the practices you have to solve many examples of multiplexer, and this multiplexer concept same as a demultiplexer. Only one changes: for multiplexer many input one output, and for demultiplexer one input many output. That only change, only one concept. So study well as a first multiplexer, and next lecture we study the demultiplexer.